Hello, calculus fans. So there's three applications to physics and engineering that we're going to be interested in. We have work, and that's a technical physics term, hydrostatic pressure and force, and moments and centers of mass. Now, force is a technical physics term, and it describes the push or pull on an object, kind of like the horizontal push of sliding a book across a table, or maybe even the gravitational force of Earth pulling an object downward. So in general, if an object moves along a straight line with a position function s of t, then the force on the object in the same direction is defined by Newton's second law of motion to be force is equal to mass times the second derivative of the position function with respect to time. And of course, we know that the second derivative of position is acceleration. So this is force equals mass times acceleration. M is the mass of the object. Now, what are the units when we are dealing with force? Mass is measured in kilograms, position is measured in meters, time is measured in seconds. So the units on force is measured in kilograms times meters per second squared. And this is used often enough that it has its own unit. That's a Newton. So 1 Newton is 1 kilogram times a meter per second squared. Now, work is also a technical physics term. So a force is said to do work if, when it's acting on an object, that object is displaced in the direction of the force. So when acceleration is constant, the force is constant, and then we can define work to be the product of the force and the distance that the object moves. So work is equal to force times distance. Force is measured in newtons, distance is measured in meters. So work is in units of Newton meters, and this also we use often enough that we'll give it a name. That's a joule. So a joule is a force of 1 Newton pushing an object a distance of 1 meter. Okay, that's all for now.